everyone, welcome back to Drawing Hub. So this is Python Programming Module 1, Part 6. Now we have to learn about loop errors off by one error. So we do have errors in loop 2. The loop fails to perform the expected number of iterations because this number is typically off by 1. The error is called an off by 1 error. Okay, so we are having off by 1 error in the loop error. For the most part, off by one errors result when the programmer incorrectly specifies the upper bound of the loop. So this error in the loop occurs when the programmer incorrectly specifies the upper bound of the loop. The programmer might intend the following loop to count from 1 through 4, but it counts from 1 through 3. Count from 1 through 4. So we will be like, as I told you before in the previous video, that is on part 5, I have told you, wherever we are giving the upper bound, it will be displayed 1 minus. So here I want to display from 1 to 4. That is why I have given here 1 to 4, but the program will be only displayed till 3 because it will be displayed 1 minus the upper bound. Okay, now loops that count down. There is another example. All of our loops until now have counted up from a lower bound to an upper bound. Once in a while, a problem calls for counting in the opposite direction from the upper bound to the lower bound. Now here, for count and range 10, 0, minus 1. If we have given, in the previous video I have told you about giving 2, 11, 2. So it skips 2 of it. Now what will happen if I give minus 1 in the same condition? It will go reverse. It will count reverse. Okay. So I am giving here minus 1. I will get the reverse of it. It will go back. Now here is not about the sum. I don't want the sum over here. Okay. It's not printing. I have to give I have to go minus, I have to go negative. Starting from 12. So 12 is my lower bound and 1 is my upper bound. So it has to go reverse. Minus 1 to count it reverse. So 12, 11, 10. Now if I give here 2, so it will skip 2 values negative. So 12, 10, 8, 6, 4. That is going reverse. Now, conditional iteration. Now we are having another loop. We have studied about for loop. Now this is another loop called while loop. Conditional iteration requires that a condition be tested within the loop to determine whether the loop should continue. So in the while loop, we will have to give a condition. So if the condition is true, the loop will continue. And if the condition is false, the program will come out of the loop. And that is such a condition is called the loop's continuation condition. If the continuation condition is false, the loop ends. If the continuation condition is true, the statement within the loops are executed again. The while loop is this type of control logic, and this is the syntax for while loop. While we have a condition, we have colon and a sequence of statements. Now clearly something eventually has to happen within the body of the loop to make the loop's continuation condition become false. Otherwise the loop will continue forever, an error known as infinite loop. So if there is any error that makes the loop to continue and it will never stop, that's what we call an infinite loop, and that is an error. At least one statement in the body of the loop must update a variable that affects the value of the condition. So this is a flow chart of how the loop works, how the while loop works. So we have a condition. Now it goes to the while loop and the statement. If it's correct, it will go. Now if it is false, it will come out of the loop, and if it's true, it will continue back to the loop, and that happens. If it is true, it keeps on occurring. Now if the condition is false, it will come out of the loop. The while loop is also called an entry control loop. The while loop is also called an entry control loop because its condition is tested at the top of the loop. This implies that the statement within the loop can execute 0 or more times. 0 or more times. Why 0 or more times? That is, when the condition is checked first and the condition is false, then it goes out. So, it goes through the loop 0 times. Now, if it is true, it goes again back to the loop after executing one. So, 0 or more times the loop can be executed. While the while true loop and the break statement. So, how does that work? I'm having some 0.0, so this is a floating point. While true, data equal to input, enter a number or just enter to quit. Now, if data is equal to nothing, if there is nothing inside the data, break. Now, if there is a number equal to float data, then the sum equal to sum. So, I will get the sum. That's a simple program. The first thing to note is that the loop's entry condition is the Boolean value. So, it is a Boolean value. Either it is true or false. That is what we call as Boolean. Within this body, the input data is received. Datum is received. It is then tested for the loop's termination condition in a one-way selection statement. If the user wants to quit, the input will equal the empty string and the break statement will cause an exit from the loop. Otherwise, control continues beyond selection statement to the next true statement that processes the input. So, how does this code work? While true, the user is asked to enter a number. If the user wants to quit, he just have to press enter. Now, the first condition, if data is just an enter, come out of the loop. It is not asked to go into the loop. While if the number is a data, if it is in a float format, then I am asked to get the sum. Okay. Otherwise, the control continues beyond the selection state. So, it goes on. Selection structure iteration we have told what the for loop and the while loop. Then comes the selection structure. The selection structure have if and if else statements. Selection structure have if and if else statement. In some cases, instead of moving straight ahead to execute the next instruction, the computer might be faced with two alternative courses of action. If else like that. The computer must pause to examine or test a condition. The condition in a selection statement often takes the form of a comparison. So it will be either true or false. First one is if-else statement. The if-else statement is the most common type of selection statement. It is also called a two-way selection statement because it directs the computer to make a choice between two alternative courses of actions. There will be two of it, and either we have to make it is correct or we have to choose if it's wrong. Here is a Python syntax for if-else statement. If else. So only two conditions are there. So if condition number 1, okay, call it, we give a sequence of statement, else. So we give a condition. If it is not, then print something else. The condition in the if else statement must be a Boolean expression, that is an expression that evaluates whether true or false. The two possible actions each consist of a sequence of statement. Note that each sequence must be indented at least one space before the symbol. So look over here, the indentation. Whenever there is a column, there will be an indentation space, and else should be parallel to if. Note that. Now, lastly, note the use of the colon following the condition and the word else. A flow diagram of the semantics of the if-else statement. So, I'm having if. If it is true, then it should go through a sequence of statement 1. Now, if it is false, it should go to the statement 2. Okay. An example for if-else statement. First equal to int. I'm asking two variables, first and second. See, two variables, first and second. Int. Input, enter the first number. Input, enter the second number. Now, this is my first condition. I'm using the if loop. I'm using the if statement, not the loop. Okay. If first greater than second. So, the number I have entered first, if it is greater, then maximum equal to first, minimum equal to second have to be printed. Now, otherwise only one condition is there. The second will be greater than first. So, I don't have to give that as a condition. So, else maximum equal to second, minimum equal to first, and then we have to print it. That is a simple code. Now, if statement, This type of control statement is also called a one-way selection statement because it consists of a condition and just a single sequence of statements. If the condition is true, the sequence of statements is run. Otherwise, control proceeds to the next statement following the entire selection statement. So that is if statement. Only if. Okay. A flow diagram is also given. So there is no false statement. It's just about true. Now, multi-way if statement. Occasionally, a program is faced with testing several conditions that entail more than two alternative courses of action. It's not about two, but there is more than that. The process of testing several conditions and responding accordingly can be described in code by a multi-way selection statement. The multi-way if statement considers each condition until one evaluates to true or they all evaluate to false. So we have if, and here we have the keyword elif. Elif. So if condition 1 colon, we have a sequence of statement. Elif, there is another condition. Okay. Now again, if there is another condition, we'll use elif, another condition. Now then at last, else, default sequence of statements. Example. Now number equal to in the input end of the numeric grade. I'm entering a grade. If the number is greater than 89, then letter equal to A. So the grade is A. Elif. If it is greater than 79, it is B. If it is greater than 69, it is C. Else it is F. Okay, that is how it works. Now switch statement. A switch statement is a very useful and powerful programming feature. It is an alternate to if-else-if ladder statement and provides better performance and more manageable code than if-else-if ladder statement. Python language does not provide any inbuilt switch statement, so we have to implement this feature with the same flow and functionality but with different syntax and implementation using the Python dictionary. We have a Python dictionary for this. This is the syntax of switch statement. We're having switcher equal to key 1, value 1 by method 1 function. So this is a basic syntax. Now implementation, we are having a function get weekday and argument. So switcher is equal to, inside the parenthesis, 0, that is our first case, Sunday have to be printed. 1 colon, look over here, this is the next 1 colon in quotation mark Monday, comma 2. Like that, how many cases we are having, that must have to be printed. And return switcher dot get argument. If it is something else, we have to print it as invalid day. Now print weekday, get weekday 6, get weekday 8 and 0. So we'll get, what is 6 over here? Saturday. 8 is not there, 0 is Sunday. So 8 we have given, it will be invalid day. Augmented assignment. The assignment symbol can be combined with the arithmetic and concatenation operator to provide augmented assignment symbol. So we need an augmented assignment symbol. So plus equal to, minus equal to. Okay. So that is making the code smaller. So a equal to 7, this is the basic assignment operator. Is equal to I, this is also basic assignment operator. So I am using a plus equal to 3. Here, this is another form of writing a equal to a plus 3. So instead of writing a equal to a plus 3, I've shortened it. That's it. Like that, a minus equal to 3, a into equal to 3, a by equal to 3, a mod equal to 3. Like that, it is given. Formatting text for output. Many data processing applications require output that has a tabular format. In this format, numbers and other information are aligned in columns that can be either left justified or right justified. We'll justify. A column of data is left justified. It is left justified if its values are vertically aligned beginning with their leftmost character. A column of data is right justified if its value is vertically aligned beginning with the rightmost character. A column of data is centered if there are an equal number of spaces on either side of the data within that column. The total number of data characters and additional spaces for a given datum in a formatted string is called its field width. All these things are theory. The print function automatically begins printing an output datum in the first available column. The next example, which displays the exponents 7 through 10 and the values of 10 power 7 through 10 power 10, shows the format of two columns produced by the print function. So here, for exponent in range, so lower bound is 7, upper bound is 11, and you need to print the exponent 10 power exponent. So 7, 8, 9, 10, along with that 10 into the number of exponents that is printed. So Python includes different times we can get. So Python includes a general formatting mechanism that allows the programmer to specify field widths for different types of data. The next session shows how to right justify and left justify the string 4 within a field width of 6. So we have a string 4 and this we have to right justify it. So right justify means modulo 6s. Right justified. So this much space is it. Now we want to left justified modulo hyphen 6s and then modulo. The first line of a code right justifies the string by padding it with 2 spaces to its left. The next line of code left justifies by placing 2 spaces of the string right. The simplest form of this operator. So we have a format string, modulo and the data. This version contains a format string, a format operator modulo and a single data value to be formatted. The format value can contain string data and other information about the format of the data. To format the string data value in our example, we use a notation modulo field width, the s in the format string. When the field width is positive, the datum is right justified. When the field width is negative, you get left justification. In the field width if the field width is less than or equal to the datum, print length and character, we don't have to do any justification. No justification is added. The modulo operator works with this information to build and return a formatted string. To format integers, you use the letter D. So we use letter D for formatting integers and for string it is S. To format a sequence of data values, you construct a format string that includes a format code for each datum and place the data values in a tuple following the modulo operator. So we have examples which we'll be discussing in the next video. So then bye bye.